Hi, my name is David Kitching. This is Group 14, or what's left of it, and I've been working on a small web app called Focus that uses the computer vision APIs from AWS, Azure, and Google. So because of the small group size, the project statement from the beginning was really just to explore what's required to set up and use these vision APIs and compare what you're getting back in return from each of them. Now, I felt that the best way to explore using and comparing these APIs was to just build a tool to easily compare the outputs of each option. And that's exactly what this web app is. So the practical applications of this specific project is the result is going to be an actual application that gives a simple and easy way to play around with these three APIs and compare what each sees in an image that you feed it. This is useful since the best cloud provider for what you're doing may actually depend on your use case. While all three of them work in a similar way, there are some differences in what they do best, which we'll explore in a minute. This specific example uses just the object labeling APIs, which is by far the least interesting option that either of the three providers give you, but it is relatively consistent in terms of what they can do on each platform. So really, what's the point of all this? On the implementation side of the project, this is a very general implementation. From working with this, you're going to have a better understanding of how to set up your own web app and your own API that calls these computer vision APIs. An endpoint like this can be modified or repurposed for any number of other projects. In building and deploying something like this, or even using this as a starting point, you can see at a glance very quickly what these APIs are like to work with. Also, for each of the three cloud providers, in general, their vision APIs tend to look and work pretty similar. This means that if you can set up something basic like this, you can use a lot more of the functionality they offer with pretty minimal modification. We have a web app frontend, which was written in React. This is mostly just because it's very familiar to me. I've used it many times before for different projects. But it also makes building web apps like this relatively simple because it abstracts away most of the complexity with data handling and animations, for example. It's also just more JavaScript, and having everything in the same language and tools and writing the backend as well just makes this process a little bit simpler. And the React app is built and deployed to AWS 3 and hosted as a static site there. This is actually a very simple process with AWS command line tools installed. It's just 2 commands to have everything build, synced, and updated in seconds if needed. For the server backend, we're just running Node and Express. This is a minimal web framework that's perfect for our case where we're only using one endpoint and taking and returning the same type of data every time. It's also being hosted on a DigitalOcean VPS. A third-party option was required in this case for performance testing for upload speed. And because it's Node, we're just using the JavaScript APIs for each cloud vendor. One thing of note, this did mean having to pick up a better understanding of how JavaScript asynchronous code works and promises, which is a bit of a new concept, but was worth learning in this case. Where things did get a little bit interesting is in the cloud storage options. With S3, you just create a private bucket, upload your files there, and the Vision API can access those no problems. This is a very easy setup. With Azure, on the other hand, if you plan to use their blob storage, their API actually requires a public URL. You're not able to just access it knowing the bucket and file name. This is definitely not ideal, so you're going to have to do some additional security measures to make sure those files aren't just accessible on the open internet. With Google Cloud in this case, it's sort of a similar story. In theory, their Vision API supports their object storage directly, but for whatever reason, I was just not able to get this to work, even following their examples exactly. So for now, for Google Cloud Storage, it just uses a public URL. This is not the end of the world in this case, since the files are deleted immediately after they're used, but it's not ideal. And then from there, getting the data needed is as simple as calling the functions in Node directly. Here's a very basic example of how to do this with AWS, for example, where we're first uploading the file to the bucket, waiting for that to complete, running the function on the file, and then finally deleting the file before resolving with the data we're getting back from the API, the upload time, and the process time. This might look like a little bit of a strange promise chain done in JavaScript, but it was done this way to make it a little bit easier to get the upload time and then process time. All right, time for a really quick demo. First things first though, this is actually the URL here for the site, and it is live right now. So if you wanted to go play around with yourself, feel free to do so. But here we go. All right, here we have the React site here, where we can upload an image and see what we get back. So let's pick an image here. Let's say this one from a recent car show. So we're uploading the image to our node server, and then from there, it's getting uploaded to our 3 cloud storage options, and then we're running the vision functions on it from there. And so here we're seeing the image that we've uploaded, our 3 different options we have to choose from: AWS, Azure, and Google, and then our response. So here's our time taken to upload it, processing time for AWS, and our received tags along with their respective confidence values. And then scrolling down even more, we can look at the actual JSON response we're getting back from the cloud provider here. And in this case, this is AWS. We can go over to Azure, which has relatively similar tags. And then Google, again, relatively similar responses to the other one for this one. The actual JSON response for Google is a little bit interesting. We have score and topicality, which is exactly the same thing in all of these cases. I'm not sure why that's redundant like that, but let's try a different image. This one, for example. This is a good example of one that shows the differences between AWS, Azure, and Google, in my opinion. For AWS, we see things like car, logo, headlight, tire. These are all things that actually are in the image. Azure, same thing here: car, automotive, auto part. But if we go over to Google, we see the same sort of thing: vehicle, car, but also supercar, Porsche 911 Classic, Porsche, Porsche, Porsche. These two actually aren't correct, but this one is. This is actually a Porsche 911 Classic right here. All right, let's try another example image. This one was taken at a wedding a couple of years ago. Here we're seeing our responses from AWS, from Azure, from Google. And here we can see even more of the kinds of differences you can expect from these 3 options. With Google, we're seeing some things inferred based on this image that aren't necessarily showing up in the picture itself. Like, for example, fun, or maybe party, you could even say. I think you'd have a difficult time saying that fun appears explicitly in this image somewhere, but it's being inferred from some other things it's seeing. The same thing with Azure. We're seeing the same types of responses, but this one sort of stands out. Drinking here is actually a verb. This isn't something that an actual object that appears in the image. This is something that people are doing in the image, which is unique to Azure, it looks like, from most of the images I've tested. One other thing that this site is useful for is comparing the JSON responses next to each other side by side. Here we have what the response for Azure looks like here. It seems relatively easy to read. With Google, again, this is kind of a strange looking object we're getting back. We're getting back some empty arrays based on things we didn't ask for, and again, null things that aren't included. I'm assuming that all of the functions available return something that looks relatively similar, which may be convenient in its own way, but isn't here. And if we go over to AWS, we actually see something that isn't present in the other 2 examples. This parents tag here. So here we see one named dating with a confidence of 90 with a parent of person. This means that the dating tag here is actually related to the person tag that we were also given. We're also given an instances and a bounding box thing here without explicitly asking for it. And again, we see wine with 2 parents of alcohol and beverage here. On Azure and Google, you may see tags like this appearing that are somewhat redundant, but having this parent and child relationship probably makes it a little bit easier to parse and makes dealing with redundancies a little bit easier. So that's the site as it is. It's certainly nothing extraordinary, but it is fun to play around with and see what different images and the 3 cloud providers give you back for them. As for the cloud tools that are actually being used for this, we have one S3 bucket here for the React site itself. We have 3 different buckets on each of the 3 cloud providers, all of which are empty at the moment. These are for storing the images as they come in before they're being processed, and they're deleted from there as soon as the processing is done. We also have the Route 53 page for the actual DNS for the site. And then this is the DigitalOcean droplet, which is currently hosting our node server right here. Our DigitalOcean instance here is a very small 1 vCPU, 1 gigabyte of RAM machine that's Node.js optimized right out of the box. And again, the URL if you wanted to use the site is focus.auburn.cloud. Now that we've seen it running, there are a few things that are worth mentioning. For performance, we have two metrics, which is the upload time to get the file into the object storage, and then the process time from the object storage to get the relevant data out. For upload speed, AWS and Azure are pretty close together, but Google is significantly slower. It's hard to say whether this is just time to get the first file into object storage rather than just their general upload speed, but it is worth mentioning. For actual process time when processing the file, Azure and Google are usually pretty close together at usually less than a second. AWS, though, on average, is about 50% higher, at a little bit less than 1.5 seconds. This may not matter for all use cases, but if you care about minimal latency when processing files, this is something to watch out for. So it's pretty difficult to pick a winner of the three based on what they return, but there are some interesting differences. AWS, for example, is probably the most consistent of the three. Even if you give it a difficult image, it's the most likely to give you relevant information about it. There's also a parent-child object tag relationship, which is pretty interesting. It makes removing redundant information a little bit easier, as well as making the responses a little bit easier to parse. Azure, on the other hand, is definitely a little bit less consistent, with the most likely to return few or almost no tags for a difficult image. But it's also surprisingly insightful in a few specific cases. For example, it's the only one of the three that I've consistently seen it give adjectives and verbs back. For example, if you put in a picture of a person on a bicycle, you're not just likely to get person or bicycle, but riding out of it as well. I can definitely think of a few cases where this might be very useful. Google is probably a little bit more consistent than Azure, but not as consistent as AWS. However, one thing it's very good at recognizing is brands and products. If you give it a picture of a car, you're more likely to get the make and model out of it as well, for example, rather than just the type of vehicle. You also tend to see very high-level, insightful responses from it as well. If you give it a picture of a crowd, or a party for instance, it's not just going to return things it sees in the image. It seems like it's going to infer things based off of what it's seeing as well. I think Google is actually the most interesting one of the three to play with because of this. Now, I certainly can't say this is an amazing product or anything, but it is kind of cool to be able to see the responses from these three APIs right next to each other and compare them for the same input. I've actually given out the URL to the site to several friends who aren't CS students, and it's pretty interesting hearing how surprised they are at how well these APIs work. So if anything, this site is just a pretty easy way to play with these APIs and see what they can do. As for recommendations and future work, I would definitely recommend reading through the docs and see what kind of functions these computer vision APIs have to offer. Some of them are a lot more interesting than the ones used here, and they're worth reading through. All three options have very generous free tiers, including Azure Vision, which allows up to 20 requests per minute indefinitely. I would recommend getting familiar with asynchronous functions in JavaScript if you haven't used them already. DigitalOcean is a really excellent VPS provider. They're even easier to set up an instance than using EC2, for example. If you're using Node.js for a server application, definitely be familiar with PM2 as a process manager. And if you need a domain name pointed at anything at Amazon, I would definitely recommend using Route 53. An example of some of the other functions that I definitely want to play with more is the Azure Image Descriptions function. Being able to put in any image and get out a human-readable English description of what's in the image is incredibly cool. And outside of the obvious accessibility functions, there's a lot of interesting stuff that I think can be done with this. To finish off though, I don't think there are a ton of things I would have done differently for this project, but there are some other considerations. In this case, we uploaded the image file to the local object storage on each provider before running the vision functions on it. This was done specifically so we could measure the time that is specifically taken to run the vision function on the image. But if you're running this in a production environment, I wouldn't necessarily do it this way. All three providers allow you to upload the image in the API call, and unless you have a specific reason not to do it that way, that's what I would suggest instead. Also, for the scope of the project, if I had more time, resources, and team members, I would have liked to look into some local pre-trained options such as YOLO v3 and compare that to what you're getting from the cloud providers instead. So thank you very much for watching. This is where I would normally ask for questions, but unfortunately certain world events have made that quite difficult. My email inbox is certainly open if you want to talk. And thank you for the very good semester. This has been a very fun class. Thanks again and see you around.